Okay, just a quick update on the printer. Well, this probably won't be a quick one actually, but basically I have almost no, in fact I have replaced every part in the printer that was printed prior to me receiving it. Every part that was a original Solidoodle print as part of the machine has now been replaced due to the fact that their designs are poo. We have the carriage here that in my previous video you would have seen that was broken on the base here, as you can see where I've joined it there and there. That was broken in shipping, and apparently now they ship with this carriage zip tied securely, which still I'm not sure would have stopped that from being broken. I think this was more of a side impact, although it could have also just been the carriage slamming into it if the motor had moved. I don't think it was zip tied securely either. As you can see, their prints that they supply on the unit are pretty poo. There's blobbing and junk all over it. There's a little bit of melting there from the hot end, and there's blobs, all this blobbing along here, and this is why I think they actually set their extruders, because I think this is actually printed on the Solidoodles before they shipped out. As in my previous video, you could see the bed had the footprint from one of their filament holders, spool holders, on the bed, so that mine had been used to print one of these jobbies, and this is also covered in blobbiness and junk like that. So I reckon they set their extruders, because it was over extruding by almost 50% when I received it, and when I calibrated it was pushing out almost 150 millimeters instead of 100 millimeters when I said to extrude that. And I think that's half the reason they get blobbing, and it's also, I think, helps make sure it binds a little bit better, because it's extruding a lot more than it thinks and pushing it into the bed. Now I am also not impressed with their brass bushes in here. As you can see, they've got brass bushes just about all throughout the printer. It was brass bushes, which again, and there we go, there's some more brass bushes there on the carriage, and this end had Teflon. Now this ran with the bar through there, and there's a Teflon piece top and bottom, so this is not even a bush. And this was so loose it was flicking up and down by like half a centimetre when I received it. So I had to tension all that, and it's all requires a lot of calibration and tweaking when you receive it. And you can see it's all their prints are all covered in strings and blobs and really crappy prints that they give you. So that's the original carriage, which I kept, and I bought new 8mm stainless steel to replace these rods with for my own carriages that I printed. Well, they're not my design, but the actual slide on mine is my own design. It's just the end pieces that aren't. So that's a modification I did, and prior to putting in an Acme screw, which I'll show you in a minute, I installed this. It held a nut above the Z axis screw. The nut was captive in there, and these went round the rods. Let's see if I can get this in shot. I'm actually plugged into the computer at the moment, giving me power on this camera. So up the back, this rod here and that rod there, and there's the Z axis screw. This was placed between those two rods, so the cutouts either side would stop it from unscrewing, and there was a spring and then a nut, and that helped reduce the backlash that's in it. And that brass nut at the back there now is actually the same principle, but it runs on the Acme screw, which is actually a lot. We'll focus on it. There we go. As you can see, it's actually a lot coarser thread, but it's a lot more accurate. This is the same kind of thread they use on lathes for the lead screws on lathes. And I bought that from a website called RoboDig. It was only $35 with a new NEMA motor. So actually I think the anti-backlash nut was another $10, so $45, but it does come with a standard nut. So other parts that I have replaced would be these here, which is that the right one? That is, which hold the idle pulleys for the slide. So this would be mounted there, and the idle pulley would then mount the pulley, so it goes that way up onto there to move this backwards and forwards across its rails, i.e. right up in here. So these ones here actually have small bull races up in there, and instead of the hose clamp on the end of the slide or the bar here, it actually clamps into the plastic. So these are, you could probably park a car on top of them and they wouldn't break. Very strong, very rigid. The original ones that I printed didn't have the bearings, because the original pulleys, they just had the bolt. So idle pulleys, these ones, they just had a bolt running through here, bolt running through there with the pulley mounted on that, so it just spun on the bolt, and of course that's going to wear the pulley away and get a lot of slop and junk like that in it. So these new ones will prevent that completely because they've got ball races. So this is pretty much what they look like. So this mounting hole, so this is the original kind of shape, but it's a much stronger there, reinforced across the bottom and there. So this is mounted, this is the left hand side, and then the rod would go in through there. A screw goes in this hole here, and a nut up in there, sorry, it goes in that hole, that side, a nut up in there which then clamps that together. And you'd be surprised, I thought I may need to cut this through here, sorry, I may need to cut that through there, the bottom of the keyway, to get it to clamp, but no, it seemed to clamp it quite well. So that I personally think is replacing them with proper bearings would be a necessity. You go from a $700 or a $400 printer, depending on which one you buy, to a proper printer. I mean, they are almost toys when you first get them. As far as calibration and everything else, they are a bit poo and require a lot of work to get up to running. But the advantage is you do have a 3D printer to print new parts. These are ones that I'm about to start printing some more of. These are vibration dampeners. I'm testing these new ones that I can't remember the user's name. I'll try and put the links underneath to the thing number from Thingiverse. And these go underneath the thing. As you can see, I've got some of the earlier designs, but they tend to collapse. There's quite a lot of weight sitting on these. So I'm replacing these jobbies with new. As you can see, I've got one in each corner, and then I also have another 3 of the first set that I printed up underneath. So I'm up to, this will be my 3rd set. So now we'll talk about the extruder. The jigsaw head extruder, which is just a really dumb idea. Really dumb idea. Of all the parts that are there, 2 of them are intact. The rest are broken. All these little pieces are all broken out of the jigsaw. It was still working and held together when I pulled it apart, but acrylic, it gets hot, everything else expands and contracts, and it might get an impact if you crash the bed, which yes I did. But within this was about a week, maybe 2 weeks after that I got the printer, I completely replaced. No, it would have been a week. It was one of the earliest prints that I did. was to replace this with a different type, and that's when I discovered it was destroyed pretty much. So this is poo, and I think it's just to save a little bit of time where they can get these laser cut instead of printing them. But personally, I think there'd be much better ways of going about it than using acrylic. Or the design needs to be improved to make it stronger. There's too much in the way of small little all these little pieces that go on the corner there like that. There's just this tiny little, let's see if I can do it here so you can see it. There's this tiny little, is that one? That would be, there we go, that piece belongs right there. You can see it's just this tiny little section. You can see it's just this tiny little section that's going to break, and my camera won't focus on it, doesn't want to play nice. Yeah, right next to the extruder mount, so of course it gets any impact right on that point. Bad design. And I think it's all in aid of saving a little bit of time. I've also replaced all of the pulleys with pulleys from RoboDig instead of being these, I can't remember the name of them, it's the T2.5 or something is the ones I've replaced it with, and these are the ML, something like that, I can't remember. But basically all the belts in these pulleys, they are all, the teeth in this pulley, in these timing belts, they're square, right? So each tooth on the belt, line down, line up, line, you know, we're talking square teeth. So of course that's going to cause backlash because there's nothing pushing the teeth together to stop kind of side to side movement. As in, you've got a square tooth and any movement like that is not going to be cancelled out. Even if it's bottoming out on the slot, you'll still get movement like that. So there's going to have backlash in it. Now the pulleys that I replaced it with, which look like, let's see if I can get the belts to it, and see if we can see it, which look like these. So they're also full metal pulleys, and I did have to actually turn the holes down in some of them because the rod's a bit bigger than, like the idle rod across the back is a 6 or 7 mil rod or something like that, I can't quite remember now. So I had to turn there, I had to put this in the, chuck this up in the lathe and then take out a bit out of the middle, drill it out. Same with the rods, the original rods that were on it, it was 0.001 of a millimetre difference, or 0.002 of a millimetre difference, and it was just enough to get the linear bearings to bind a tiny bit. So I chucked up the rods in the lathe and just machined them down, or not machined them, just polished them basically. Now, I'll see if I can get this to focus. This is the belt I replaced it with, and you can see these teeth are curved. Okay, so that's the replacement belt. And this belt, let's see if I can get it to focus on both of these. So if you can see that, the belt that I'm currently wiggling is the original style, and it has square teeth, and the replacement belt has curved teeth. So what that means, as I said before, square tooth, you'll get slop in it like that and like that. Whereas if you have a rounded tooth, let's imagine the top of this is a tooth, so we're looking at it like that, it can snuggle up, and they're actually the belt, they're not even rounded, they're almost a semicircle, so you're talking a tooth like that, so you get this nice curvy lump. And of course that's going to bury itself into the slot and not get sideways movement, because it's sitting, it's held nice and tightly, so it's not going to have the slop. You don't even need, it doesn't even need to be bottomed out. If you don't actually want it to bottom out, you need the tip of the tooth not to be touching the piece of belt in the middle. Because of that, there's a lot less backlash on these nuts. And if anyone who doesn't know what backlash is, it's basically, there's always going to be an amount of slop in something that's going to go backwards and forwards. And backlash is if I'm pushing this way and then that way, and say I'm a pulley or a tooth in the pulley or whatever, something that would have backlash. Backlash is when you go, okay, it's now moving, every forward movement that I push will be what I tell it. If I say a centimetre, I'll do a centimetre. Now if I say to go in the opposite direction a centimetre, I'll go a centimetre. And then of course I haven't even moved the object yet, but I have moved a centimetre. So it's not until I contact the part that I'll actually start moving it accurately, and that slop is what's called backlash. So you want that to be minimum, little as possible. And this unit was full of backlash in the slop, in these bushes, lots of play, and anywhere that has play will actually cause backlash and inaccuracies. Same with those pulleys, as they were wearing on the shafts instead of having bearings in it. You just turn on the thing and wear out the inside of the pulley. Okay, so I've spun the printer around and we're now looking at the back of the printer where the control board is. Now I recommend two things to buy while you're waiting for your Solidoodle. One of them is get on eBay and buy half a dozen 40mm fans, because you will inevitably stick your screwdriver in through one of these on the back of your extruder when you're fiddling around behind there and smash the blades off of it, which I've done. Not only that, you'll need them to cool down the carriage stepper motor as it gets almost, take your fingerprint off, kind of hot. And you will also need them if you don't have these. See, I buy good quality ASUS motherboards, and a lot of them will give you these little fans that are designed for passive CPU coolers, and you can't really use them anywhere else. They're designed to clip over the MOSFETs and the regulators on the side of the CPU to keep them cool. So I've got 3 or 4 of these guys now, and you can actually buy them on eBay for about $4 or $5. And what I've done is mounted one above the Senalo, or whatever they're called, the Arduino and stepper controller board on the back, to keep it cool, because even I found within an hour it was stepping, and it's due to these guys getting too hot and then they shut off for a second and then turn back on again, which means you've missed a few steps in your print, and you'll find that you'll be printing and then it'll print another layer, but instead of being on top it'll be stepped over a little bit, and it'll generally be on one axis. I think it was the Y axis I think I was having the problems on mine. And also they don't come with heat sinks on the boards, which they're supposed to have little heat sinks on the stepper controllers. So I bought little heat sinks and put them on there, and although the fan did seem to solve the problem, but I think if it's in a hot room it's not going to solve the problem. And I also actually glued on each side here, there's just a small little thin strip on each side here there's a small strip of acrylic just to make the fan, as it's blowing air through, it'll blow it all the way through and out the bottom. I feel a little bit of warmish air coming out there. One of the other things I need to replace is this dodgy little block for the main power input. It's a bit wussy looking, so I'm thinking of just actually soldering the wires in directly, because I did add this terminal block down the bottom here to give me more areas to put run fans and this kind of stuff off. As you can see, there's this. I have to also do some wire management and clean up a lot of these guys. Like this is another fan I added in. This is actually for the other stepper motor that I bought for the Acme lead screw, which I found not only with the stepper motor, the plug was in the wrong order. So if you plug it in and nothing happens, more often than not, I would say, is your steppers are in the wrong, or each coil is in the wrong pin location. And then also if it turns the wrong direction, that means you need to reverse the plug basically. So you can just play around with it. You shouldn't hurt anything. It'll either not work or go the wrong direction. But preferably get a multimeter and measure your across all of these guys, and it will tell you, or even look up the specs and you'll be able to work out which are the two coils, because these are bipolar stepper motors, so you have two coils and you'll be able to measure resistance between two wires and nothing between the other two. What else have I done on the back here? So yeah, I've upgraded and changed. Well, the fan basically is a must. You need to put a fan on. Even if you make your first print another cover, which takes, you can get them, there's covers on Thingiverse that will take a couple of fans, which is also works fine if you're still going to have your spool holder on the back here and your spool hanging off the back, which means you have to be away from the wall. The reason I did this is so I can, even if that's completely covered, it'll still suck a bit of air in through the back here and still do a little bit of cooling. So whereas if it's these guys here, then they're not going to do much at all if they accidentally pressed up against the wall. I think that's about all on the back. I also need to do a bit more, because they use this dodgy gaff tape to, well actually it's good quality gaff tape, but it only handles being unstuck once, because it's the case gets warm and I think it just cooks the insulation. So this at the moment is just hanging out in the breeze. I have to make a little holder for that. As you can also see from my power cables running out here, I've also completely replaced the power supply, which I will show you. Due to the power supply they had, it still works, but it's pretty wussy. I'll get a torch in here. So let's just shine that down there. And again, this is a cheap power supply, but it's a 20 amp 12 volt power supply. And it was getting a bit toasty, so I've installed an old Intel kind of original manufacturer CPU cooler, and they just poke it. It actually just clips on there. They just poke in the holes in the top and just push in as if you're mounting it to the motherboard. Works perfectly, and just pulling power straight off the power supply. I've also cranked the voltage up on this to 14, I think it's about 14.5 volt, which is high as it goes. And there's all regulators and everything on the Arduino for 5 volts. As long as you have a fan to keep the regulator cool. The regulator's happy all the way up to 35 volts. And it just means your heat bed has a bit more balls. And your basically everything just has a little bit more grunt, which is a lot better, because I found it would take me half an hour to get to 94 degrees on the heat bed, but I have changed the heat bed as well, which I'll show you. But it would take a very long time to get up to temperature, so I think that's about all on the back. And I will actually be mounting that power supply, will get mounted here most likely, and I'm going to probably print a custom enclosure which will have a couple of 40mm fans blowing through the enclosure or something like that. I don't think it needs a lot of cooling, but it does get a bit toasty, so which I also found the standard one that they provided got very toasty also. It's basically just rated enough. Okay, so on to the interior. Going from the top down, we have my dodgy little lid to cover the spool, but it just helps keep a bit of extra heat in. And I've also found that I've heard a lot of people talk about problems with moisture absorption and all this kind of stuff. I think keeping your spool on top is probably the best idea, because it cooks any moisture out of it. I mean, this is toasty warm. It's not hot, but she's nice and toasty, and that bed's been on for a little while. I've been talking now for half an hour or so, and we're at 95 degrees. So that's my enclosure, which is all held on with magnets, and I've got these. I had to build these extra bits onto it because of the other carriage that I've printed, which I'll show you in a second. And I printed these spool holders that the PVC pipe just clicks into the top and just locks in. And I've had to use a couple of these office clips, or whatever you want to call them, to keep the dust on there. A bit of fluff. I've used these office clips to keep the filament from. It can pop over the edge, especially when it's a fairly full roll. This gets over the edge and then starts winding around the spool holder. So these just act as guides to stop it from flipping over. Now I'm actually going to take the lid off so you can see it better. So this just sits on top and just lifts off. It's all just made out of acrylic and super glue, which is good when you get it to work properly, and a pain in the ass when it doesn't. Now I've got this rubber band, slightly dodgy rubber band set up here to hold my cable for the extruder up and out of the way, because it tends to rub, pokes in under here, gets squashed up, rubs on the belt, rubs on here, and gets folded up in this really tight, squished up bloody U in the corner. So this rubber band, basically, as it comes into the back corner, it holds it up high so it will go up and over here, like so, instead of folding up into the corner. Now I've put on some office clips here and removed the little levers, and it just basically smooths this corner out so it's nice and smooth, and it's not going to wear the fabric here along this sharp edge. That one's just there for storage, basically. Now the carriage itself, I've got half of one guy's extruder set up with an easy push and release filament. So you just simply push that and it will release enough to pull the filament out. The one Lawsy made is the guy who has the Mark IV, I think it was good. It had the original kind of pressure spring on the, I found the idle bearing wasn't turning and it was being a bit weird, so I've replaced it with this one. I find this works quite well. The bottom half is still his design, and I think this little fan blower is also his design, which I pretty much leave on all the time, and I've got some blue tack to hold it in place, because I found it can vibrate loose sometimes. Now this section here of the Mark IV extruder is my own design, because I found it was supposed to be easy to change the hot end, but there was nothing holding it in from this side, and I had lots of flop and wobble and all this kind of stuff. So you can see now it's steady as a rock. So this cup's in there and clamps on, it means I can still use the accessory clips like so. Push down this boot tack a bit, and I'm just using these little header strips, much like these, and I just cut them down, and I've been using them as plugs for fans and that kind of stuff with a bit of heat shrink, rather than spending 20 cents on some other plugs. I've had zero problems with them so far. It also means if, like, this fan got knocked off, it also means that if it gets knocked off and falls, it will just unplug itself as it falls. What else have we done? So this runs on my own design carriage. There needs some tweaking before I'm going to release it, but I actually used filament, glued some filament along the front edge here to hold in 2 linear bearings. So there's 2 at the back, 2 at the front, 1 at the back. It's the same, it's actually a bit longer than the original one, but it's the same width as the head, and because of these new carriage ends, these will actually provide extra space, because I can get that off, just held on with magnets. This idle pulley was originally on the other side of the bar, so it was located about here. So now I've got that much extra room, and same on this side. I'm running out of cable on my camera. That motor was originally on the inside and is now on the outside, so you can see it gains you a good 1.5 inches or whatever of print. And the blob on the bottom is a little fan thing to keep the stepper motor cold, again with a 40mm fan. I have had problems with it rattling loose. It's supposed to be a push fit, but I just put a tiny dab of super glue on it, and now it seems to be holding fine. As you can see, I've got weather stripping on my enclosure to keep it sealed, and also just keep a bit of noise down. You can see I've replaced the belts with the T 2.5 or whatever they are. These carriage ends have linear bushings in them also. As I mentioned before, I've replaced the leads, the Z screw, with an Acme screw, which is a lot more accurate. But this number of steps has gone down by from a few thousand per millimeter down to a couple of hundred, which is not a problem, because that's not where you get the accuracy. You get the accuracy in the thread, not the steppers. I'm printing on glass, and I have a Persa Mensel, I think that's how you pronounce it, heat bed on top, which is again running at a slightly higher voltage. And it's good because it's got the little lights in it, and it's slightly bigger, but my sheets of mirror are actually a little bit too small. So what I'm going to do is, I bought a big 5mm mirror, and I'm just going to cut some pieces to size. I'm going to have to work out a mounting solution. And this heat bed is basically glued to the original one in between, which is fun getting it screwed back on again. I basically broke these little captive nuts that they use as the threads on the bottom, just above those thumb screws. There's some threaded inserts. I broke them loose, so now if I impact on the bed, the actual nut at the bottom will swing down, and there's just enough knurling and everything on it to still bind, so I can actually adjust it still. What else is there to say? Yeah, so I've basically replaced that whole rear idle bar at the back there, one right along there. I'm still, I had to put that in the lathe and polish it because it was all covered in burrs, and I couldn't get the bearings or the pulleys to align correctly to get the carriage to move backwards and forwards evenly. As you can see, I'm still using the original pulley on the stepper motor at the back there, but all the other pulleys in the unit have been replaced with the better pulleys and belt. So yeah, that's my update on the Solidoodle 3 so far. I've gone through a spool and a half. I accidentally bought 3mm plastic filament, and also was very annoyed with a company called, I can't remember their name, I'll post it at the bottom, and I personally wouldn't trust them because they were advertising them as 3 kilo spools and they weigh about 2.3. If they had have said it's 300 meters, not 300 meters or 3 kilos, which they've now changed their site because I lost it with them. Yeah, I would have been happy, but I mean, they were about the same price as the other ones, but I thought, oh, bargain, I'm getting, you know, 25-30% more for the same price, but no, it turns out I wasn't. And I bought the wrong filament, mainly because they're advertised wrong. Anyway, what else? And this is, I'm using this acetone, ABS dissolved in acetone to paint onto the bed as adhesive. Some parts, whoops, that I'm going to chuck on the floor. Here's some parts I designed for my lathe to hold, that will hold the chuck teeth, that'll hold the key and some of the other tools and dead centers and chuck and that kind of stuff, and all the Allen keys. I downloaded another design, but none of the tools fitted because it was for a different lathe, so just my own enough fault. So I thought I would design my own from scratch. I think that's about it. If anybody's got any questions or want me to do any pointers or how-tos, then let me know in the comments below. So the other thing I forgot to say completely forgot to say, was these bushes. These are originally brass bushes at the back, and I've replaced them with proper ball bearings for the idle bar, or the pulley bar across the back of the printer. So this is being replaced with cheapo flange bearings. They simply popped into the hole that was there. I think I reamed it out a tiny little bit, and I did actually have to turn down the end of the bar to get it to fit, but it was so close. Yeah, so I think that's about it. Oh, and the LED lighting underneath, I've replaced that with some beefier stuff, so I can see what's going on in there a lot more. Again, I wouldn't recommend doing that without replacing the power supply first, because it's pretty on the cusp of being too much for the power supply, even out of the box. Same with the heat bed. Just about all the other mods I did. Actually, I did replace I replaced the power supply when I put the new heat bed in, because it's about half the resistance, so almost twice the power, but not quite. I'll be back.